When I was growing up, I had visions of fantastical giant robots that would fight for good, and amazing vehicles that had a configuration for every situation. Cool engineers and inventor types that were knowledgeable enough to get out of any predicament. Or strong warrior characters with indestructible weapons that fought to protect that which was good. The influence of these shows told me of what I was to become, an engineer. I've spent countless hours of contemplating on how I can make that which I've seen into reality. Now I have the power to do it. I've designed and created many things, and I've been doing it for over 25 years. And now it's time for me to share my process with you. I draw inspiration from concept art, shapes, ideas, media, nature, whatever. I'm going to show you how to take a vision and step by step make it into a reality. I'll share with you the tricks that I've used to help me create things for over 25 years. Now, join me as I endeavor to create a whole new plethora of projects. From the simple, the niche, to the overly complex. This is Designed by Purpose. Check. All right. Happy Friday to everybody. Hope everybody's doing well. I am back. Sorry for the little hiatus on yesterday. It wasn't planned. It just kind of a little situation came up and I had to go deal with it. But I am happy and delighted to tell you the results are it has been solved. All is right with the world. Well, at least at this address, right? For now. So, yeah, we're back at it. Thank you for tuning in to today's episode of Design and Chill. I am, as the title suggests, I am continue to work on my radio control, my custom radio control. I'm using Solidworks. This is Solidworks 2017, and I'm using that to design it. And yeah, you're watching real-time engineering right now. I'm designing it in real time from scratch from my cranium off the dome. So yeah, we're going to be doing that, and feel free to. Well, I'm not going to. Just side note. But feel free to make comments on what you think, and let me know. But obviously, I'm going to design it the way I see fit. But constructive criticism's cool, or input. That's all good. We'll try to work with it and see what we got. Maybe we can create something together. So yeah, that's what we got going on. I'll talk a little bit about what's going on, what happened yesterday. You guys and gals and ladies and gents may find that a little interesting. It's a kind of fun story. I'm actually making a blog post about it on my blog. My blog is, what is my blog? TRSrobotics at blogspot.com. So TRSrobotics at blogspot.com. Had it for a long time. I'm just now really kind of utilizing it much more. At least that's the game plan. So if you feel, have the moment, stop by. You can see some cool stuff on there. Stuff about me and whatnot. So on the day before yesterday, when we were last together, I was working on the battery door. So I've decided to do this version of a battery door, or a battery tray / battery door. And this is the approach I'm going with so far. So what I have here is we have a door that's actually going to go through or intersect with both halves of the controller, meaning the top main body and the bottom back cover. It's actually going to slide into the back cover. I think I can move it. I don't have all the nice fancy motion and stuff set up, so but I can still move it. It's not locked down. It's just sitting there. So let's just slide it on down. Come along. Thank you. Solidworks was moving kind of slow there. All right. So yeah, okay. Yeah. You see, I went back and added some chamfers on these edges because I didn't want it to be that right angle. I'm already a little, not upset isn't the way that I should phrase it, but I did not want to make a cutout in this top portion, especially not one this big, because it's going to weaken the structure. Of course, thankfully this is printing. This is going to print with this side being down, so this will be the top portion. So I mean, it shouldn't have too much problem printing. And really, there's really nothing here as far as structure goes. There's not much. I mean, it's just really the end of the part, and a lot of these other portions can take that any stresses there. So that it shouldn't be too big of a deal. But I did want to get rid of those 90-degree angles. Let me change this view here. So I did want to get rid of those 90-degree angles. I may go back and make them curves, but right now I have them at those chamfers. Okay, and so this solution, or this part of the project, is going to be kind of two-part. Like I have the door, but I also have I need to make this little compartment, and that's where the battery is actually going to sit. Just looking at it now, I was thinking, well, maybe the wire, the actual connector and such, I can shove those in here as well. So maybe I'll add some padding. So this actually is probably a good thing, because by having this as a separate 3D printed part, I may have some room or something to change it if I change batteries or something. Like, you know, I can add the cushion, some padding on the inside walls for this particular battery. But let's say I get a battery that's a little bit, doesn't have quite the same dimensions. I can just go back and reprint a new version of the little box and then mount it in the same place. So I think that's cool. That adds a little room for change there. So cool. All right, let's continue on. I need to correct this angle, because I just have it randomly in here right now. I need to correct this angle, and I need to move this up so that it kind of matches that portion. So let's see if I can figure out what this angle is first. I'm gonna go ahead and open. Oh, no. I may have to restart Solidworks. What is going on? Let's see here. Let's see here. It's giving me that resource warning again. I'm gonna try to restart it. Oops, hit cancel. Save all. I think it's gonna close. All right, let's see here. Resources. Make sure I'm still on there. All right, let's see. Let's try to reload this. So, how's everybody's Friday so far? It is almost the end. Well, where are we at? Yeah, we're almost at the end of February. Almost. Is it 2 more weeks? It's flying by. Flying by. Let's see here. Okay, let's see if oh my gosh, it's not cool. This is not cool. Okay, so I'm gonna have to I got to free up some resources here. I think it's Chrome. I think Chrome is in the background. Just maybe I have too many. Well, I don't really have any tabs, but slight problems. Well, let's see here. Let's see if I can open this now. Come on, part. There we go. Kind of, sort of. All right, I'm gonna try to baby it today. Take it easy, not push it too hard, because it's giving me this resources warning. But okay, so what I was coming here for? Oh, I wanted to find out what this angle is. What is this current angle? I don't even remember where. Okay, extrude cut. It is 10 degrees. Okay. All right. Excuse me. Okay, we got that. We are going to open up the little box. Excuse me. I have to do some troubleshooting. I'll do some troubleshooting this weekend, see if I can figure out what exactly is going on when I try to stream. All right, let's edit this one. Oh, I'm looking at the wrong side. Okay, 10 degrees. All right, I only had it at 5. Okay, we have it at 10 now. I think the whole thing's gonna need to be a little taller. I think that's what happened. Let's take this. Let's make this 1.8125. Let's see if that I think we can leave it like that for now. Yeah, we'll leave it like that for a moment. Let's see. Okay, I see now. All right. I need to measure that. Let's do this. Let's make that back. I'm gonna chop this open. Use my cross-sectioning tool so I can get in here and let's flip that. Yeah. So now I should be able to get in here and get a little measurement. All right, if you stopped by the stream today, please let me know whether you're on Twitch or on LinkedIn. All right, we got 1.019627. Let me scribble that down. 0.10196627. All right. So let's take this. Let's just go ahead and add that to here. 0.10196627. All right. Okay, we're going to take this. Did that even change? These angles are correct now, so I'm going to actually mate that. Now it looks like I just need to fix the door. I'm actually going to mate these. Okay, so now I got the door locked in. Now I'm going to now what is this I have going on? Those aren't the same thickness. Why is that? Oh, that's because of the cut. Okay. All right, let's take this. Let's make it transparent again. All right. Remember I was talking about that selection thing? Still don't know how to do that. I'm going to do it this way. Measure. All right, we got point. Here, I'm gonna try to do it. Y'all gonna help me do it today. I'm gonna my short-term memory. 075825. Oh, that was pretty good. 075825. 075825. 075825. 072855. That's not right. Hold on. What did I just have? 25. 0850. I'm sorry. 075825. 075825. I can do this. 075825. I can do this. I should put it in the chat. 075825. Come on. We can do this. We can do this. I'm going to fix my short-term memory. All right, let's take this. I'm just going to add this to it. Plus 0.075825. Got it. I think I just have to take it slow and just kind of think about, all right, well, what are the numbers? And I think if I just take them in the pairs and take it slow, I think I can do better. All right, let's see here. Did I get what I needed? I didn't do that right. Hold on. I thought okay, that is where it needs to be. Okay. All right, so we have that. I don't know if I actually have, this is, okay, again, that is because of those. Okay, let's see, where do those need to be? Let's do this. Take that. Take this. Let's measure it. I'm sorry, cross section. Bring this over here. Flip it. Oh, wrong button. Well, at least Solidworks is cooperating today. Oh, no, that was the right button. I'll just leave it like that. Oh, come on. All right, so now what I'm trying to do is get the slot. Well, I'm trying to do a couple of things. I want to figure out, well, what is the thickness I have on this slot, on this little rib feature that I'm going to be printing. Ooh, I just have some arbitrary. So I got to go back and make that a 16th. Let's go back and clean this up. Yep. Okay. Let's see. All right. Make this a 1/16 of an inch. 0.0625. Okay, let's dimension it from front. Oh, it's right at 1/8 of an inch. That's cool. Okay, let's leave it there for now. We can do it from here. .565. Let's just leave that right there for now. Ooh, what is going on here? Why did that do that? All right, we'll just match this angle, make them collinear. All right, let's leave that like that for now. This is your first time watching the stream. Of course, I am your host, Damon Paget. Robotronics on 9. If you are if you are watching on Twitch, and you can be sure you can catch, if you missed the live stream, if you want to catch some of the back episodes, you can, of course, you can watch them on the respective channels, but you can also check them out on my YouTube channel at youtube.com/C/Moral-Rich-Media, all one word. So you can check that out. I've got more projects to come. This is just really the first of a long line of all sorts of interesting projects. I peruse through YouTube often, and I see a whole lot of stuff. A lot of stuff. Some stuff is inspirational. Some stuff is like, wow, they did that. And one thing I can say about watching videos of people making stuff, which I always find really interesting, I really find enjoyable, maybe, so to speak, is like when you see somebody make something and you know it took a lot of work. If you're a person who creates stuff, you already know. It's like I'm watching it and, like, the video maybe 12 minutes maybe, but that was like months. That was a lot of painstaking work. It was like, wow. And I'm like, better you than me, man, because I know that was rough. I was like, I'll just stick to my own little projects. So I do take pleasure in being able to watch the fruit, live vicariously through other people, watching them put in the work, and then you can watch, enjoy the benefits yourself, or at least the visual benefits. So pretty interesting. I know this. I mean, this alone is. This project is it's taking a lot, but that's also a reason why I decided to stream it, because I need to get it done, and I need to kind of not justify, but make the best use of the time that's going to take to do so. All right, so let me see if I can get this slot where it needs to be. Of course, I'll go back, and the slot needs to be bigger than a 16th. But granted, this is the prototype. It's like a prototype of a prototype, I guess. It's the first run, the first iteration. So I definitely expect to be doing some sanding and some filing to get everything just right. I'm going to go ahead and make this a little bit bigger now. 3.5. I still haven't figured out the perfect, what is it? The perfect amount that I need to make things oversized by when I'm printing them in order for them to fit. I haven't, I have a ballpark figure, but I haven't like got it down to a science. It was like, okay, I know if I do it exactly this much, we're going to be good. All right, come on. Working my computer today. It's working it. Just hold tight, baby. Just hold tight. All right. Let's see. Did we get this right? I'm going to go ahead and make these two coincident. Don't do that. Do it from this. I'm going to slide this up. Should go ahead and do that as well. How are we doing here? Okay, that looks like it's where it needs to be. I could have centered that a little bit. Let's go back. Let's take this. All right, I'm going to take that. All right, let's take this. So yeah, I'll have to go back through before I actually start doing the prints. I have to go back through and check all these mating surfaces and make sure that I've given myself a little tolerance, some wiggle room, because I know a lot of these aren't gonna go together perfectly if I don't do so. I'm gonna move this back just a little bit. Okay. Yes. Now I gotta figure out, okay, so I have this, I have the slots. It's not. Okay, we saved. Come on. Yep, we saved. And remember this piece right here. Where's the... Yeah, this piece is actually going to print like this. So I'm going to set it up in Cura to print like this. So I still have many other features. I really haven't done a whole lot with this. This is kind of, I'm just trying to finish the main portion, the top side first, and then I'll come back and work on this. All right, but that slot, that's looking reasonable, I believe. Let's go back to the main assembly. How's everybody doing today? So again, I posed this question a couple of times, and I shout out to the followers on Twitch. I appreciate it. They've asked what CAD package or what industry or what they may be designing. So far I've gotten homes, or I'm assuming that's going to be kind of like an architecture type thing, and also and furniture, but I didn't get the design package. Like, they didn't mention what design package they prefer or use. Okay, so this I see where I need to make some tweaks on this door, because there's going to be wires coming out of it, so I know that's not going to, I can't have it that tight. So I need to make some room. This is way too tight. Yeah, I have to make some room. So let's make some room on this door. I'm going to take my little feature. I'm going to make it a lot more shallow. What is that? You see that? Wow, that's weird. Okay. Let's take this. I'm going to make it much more shallow. All right, let's make it 0.03125. Okay, and we're going to take, it went away. Okay, and I'm going to take Let's do it like this. I'm going to take this rectangle and let's just take a good portion of it out. Give me a center line. Let's run that up here. Get a midpoint. All right. Now, let's get a dimension on this. We can make it 1 inch. That's fine. That's cool. And let's just give ourselves a little meat on this bottom portion. 5/16 is fine for now. Let's be smart about it. Let's go ahead and just collinear this. Ooh. I'm not sure if that point got selected properly. Okay, let's get it out of here. Cut it up. Let's cut it up. Cut it up. Cut it up. Where's the haze at? All right, let's make this 3/16. Okay, so we made that real thin. That may not stay. That may be too thin. But let's just run it real quick to see how it looks. And I may go and fillet the inside of this to add more strength. And then I can just print that part like at a high density, like over, maybe 75% or something. Okay, that gave me a little bit of room at the front. Okay, so right now the main what holds it in is the ribs up here on the bottom portion. So when I slide it in position, it should just stay here. This is gonna be pretty cool. I get it to fit up right. I'm gonna be pretty impressed. My first custom radio. All right. Okay, so now I'm gonna have to figure out a way for it to stay in there, but we'll work that out. Originally I had plans on doing like if this was a flexible, not like a TPU flexible, but like a nylon flexible material, I would make the little flat clasp. I could do that. I could take this. I could put a slot here and a slot on the other side if it was shown. See, I could slide it here, and I could have made a feature, like a bump feature, a little whatnot, and I could have made it where it would have locked into the top, a little place in there. But I'm not going to try to do that with PLA. I know it won't work. I know it won't last. Like you go open it and close it. It may do it one time. You go open and close it a couple times, and the beast comes off. I may look at find a different material. I know TPU would work, but I think TPU might be too soft, and then it's not going to look good. Not the TPU that I have. It's not going to look good. I want the finish to still be good. So I was thinking, I was trying to think of some other way. So what I was going to do was I was going to actually make more of a mechanism instead of trying to make a one part with the moving portion in it. I was going to utilize the space, but now I see that I didn't have as much space as I thought I would have in the box itself because the battery's a little bit long. So I'm gonna have to make some adjustments. And I'll probably work on this again later on this evening and see what adjustments I can make. to get this in there. Because after I get this portion done, let's see where that goes. What else is next? After I get the battery box done, I think I can move to the bottom. Okay, so here's a problem I'm just now realizing. I have this hole up here, which is too big anyway, but this hole is supposed to be for a lanyard hook. So most, like, if you look at a lot of the old Futabas, they have the lanyard hook right. Actually, they have it most of the time right up here in the middle. So if you got a neck strap, you hook it in right up here. So I was actually going to hook mine in down at the bottom, because normally when I'm using this radio, I lean the bottom down, so the bottom's pointed towards the floor, kind of, sort of, not like 90 degrees leaning it down, but it's leaning down, 30 something degrees or whatever. So I was actually going to strap in back here, but now I see that I have that. So either I'm going to have to I got to figure out where I'm going to get the needed space for the screw and stuff, the bolt, the nut. Now I have some dead space up here, but I figured that dead space would probably be utilized for the cable for the plug. I need to measure and see what the height of the plug I'll be using is going to be in there, to see if it'll actually fit in here. What is this? So that's roughly, let's say, 1/4 of an inch. You got a little bit more than 1/4 of an inch. So the plug can't be, ooh, man. I don't have a battery near me. So that's going to be something to think about. And also where the battery, cables, the wires come out of the battery. Excuse me. So I have a lot to try to figure out here, because this doesn't seem like it's going to be enough room for anything. If the battery is roughly 4 inches, then I'm already at a loss. Now I can squeeze out another maybe a 1/8 of an inch out of the back of this. I can make it 1/8 of an inch longer. That might help without overrunning the Arduino Mega too bad. So that may be a possibility. I'm not trying to move the Mega. I like where the Mega is, like its current location, so I'm trying to keep that. And I haven't even purchased this battery yet. I have a different battery. I might need to. Oh, hold on for a second. Aha! Now this isn't. I don't believe this is that bad. The battery in this model is actually a different battery. Here's my calipers. Let's see here. Oh, I got something in my calipers. But we won't worry about that. All right, so let's measure it to include this cable. Now this is my old battery from my I purchased it a while back. Oh gosh. It's 4 1/8 with the cable. Disaster. Let's get back over here. 4 1/8. Let's open this up. Again, although they're the same color, this is not the same battery. I'm pretty sure that was the case. But I'm gonna make it the same length just for this current. Let's get this off. Come back. Let's see. Oh man. 4.125. Okay. Let's see what the damage, how the damage is. Okay, that is way too much battery. But that does include, I mean, that's, ooh. Oh, okay. Well, Okay, so just so you know, the Mega was not modeled here. The Arduino Mega has a hat, or has another little board, a proto board that's on top of it. That's all really, that can all be changed later, but I do want the first version of this radio to work, so I'm going to use the proto board. So that means this space directly underneath, of course, is going to be taken up. So I would actually, and then the proto board has wires coming out of it, so it's going to take up pretty much this whole volume of space right here. So I don't really have access to that. So I have to figure out a way to hold this battery in here, which is almost too long. Now I could do some finagling. What I could do, oh, wait a second. So I don't have a whole lot of space down here either, because some of these features protrude or come up inside the body of the back. Speaking of, let's do this. Okay, they don't overlap that much, but they do overlap. Excuse me. What I was thinking was I could take, like, it doesn't necessarily have a holder. Well, really, a holder doesn't have to come out that far. It just has to come out far enough to catch the end of this battery. So I could maybe make a feature that extends out and comes up, but then is only here, is only in this part. And as long as the battery is in this vertical orientation, it would be stopped. And then you just really do the padding. Make sure you got plenty of padding on the inside to So what do we think about that? So you take the battery door, you slide it down. Let me put that back on. All right, let's take this. Let's just slide it down. Okay, you slide the battery door down. Expose the battery. How you gonna pull it out? I guess you're pulling it out by the wire, which is not good. I know that's good. I know that's not good before I ever even do it. So now I need to think about, is there a plate? Do I need to have like grooves for your finger, so you can actually grip the battery, like a groove here. Excuse me, not enough oxygen, I guess. A groove here and a groove there, so you can go in with your fingers and kind of pinch and pull the battery out. Because you don't want to just yank it out by the wiring. I mean, that's not good. I will measure a couple of connectors, and see if this space is adequate. Of course, it can still go down a little bit. Let's take the battery down a little bit. Okay. I mean, it's close. I mean, I think it's close. No cigar yet though. I like the idea of having the door that slides to the back, and you can pull out the battery. Again, right now I see this as yanking the battery out by the cables, by the wire, just because that's going to be the main thing that you can. And I mean, granted, I mean it's going to happen, but it doesn't have to be. I mean, you're not yanking it out, and you probably, once you pull out the door, you got to disconnect the battery anyway. So when you go to disconnect the battery, you're going to already be like sliding the battery out. So it may not really be an issue. Just depends on the cabling, the wiring, and how thick and how pliable it is. That's gonna be taken into consideration. All right. Oh, I noticed this the other day. I have an LCD here, but it's really exposed. Like normally when you have an LCD or something, you still have the clear top cover, and I don't have a top cover on this. And so what I was thinking that could solve that problem, what I could do is right now I have the LCD panel really at the back or the inside rear of the main body. So there's actually a section that's actually like kind of cut out so you can have an inlay of the LCD panel. What I can do, say, okay, that was kind of a mistake. I could add some standoffs to it. I could add some standoffs to it to get some height. Yeah, you see this? So I went back and I inlaid the panel, which was fine until I realized it's like, oh, well, there's nothing that goes over this. There's no cover. So what I can do is I'll keep the inlay, but I'll just get some standoffs, some hex standoffs or something, and pull this back, and then I can do. Oops, let me turn this back. Then I can if I can figure out what material or how I can make it, I can put a piece that goes right in here and is flanged to the underneath this faceplate. So the faceplate locks the piece in. I think that would be the way to go. I just need to figure out how to get a clear piece like that. What's going to be the best options to get a clear piece like that? So help me, I'll be thinking about that. I will be thinking about that. All right. So I like the battery box. I like where it's going. I still need to figure out how to connect it right. I know I'm going to connect it with ears on this side. I'll probably do it, spread them out. I may do 3. I normally don't do a lot of even things. I mean, odd things. I'm sorry. So I may do 3 ears. Since I can't really do an ear on this side, but if I get the standoffs, I don't think you can do the ear. And then if you were going to do it, you definitely need the standoffs. If you're going to do an ear or something from this side to connect the battery box to the main body, you're going to need some kind of ears. But yeah, that's all contingent on figure out how I can cover this. What plastic am I going to do some Lexan? Now I could do some Lexan. I was gonna say do like a little makeshift vacuum forming on the Lexan, and that may be what needs to happen. we'll see. But I think that needs to be covered just for protection. All right, let's keep it going. Let's keep it going. Keep it going. Any big plans for? Oh no! Hit cancel. Got a little too frisky with the button clicking. All right, so change that transparency back. Let's change this one back. All right. Do a little quick save. So on the side note, so I'll tell you a little bit about what happened yesterday. So, and like I said, I'm gonna have my blog post about it. I was working on it, but I wasn't able to finish it before the stream. But basically, the gist of it is I had to change the stem in the shower because the shower was dripping. You know, it was like a small drip. It had been a small drip for, let's say, a month or so. But I'd been kind of mitigating it or pushing it off because I could twist the valve just right and get it to where it would actually stop. So that was good. And I was like, okay, well, cool. Maybe I can hold off on it until, you know, so I have more time that I can use on it. That was the game plan. But then the other night, after the shower, after the shower, it was doing like normal. It was dripping a little bit. I twisted it. I turned the knob a little bit. Got it. I couldn't get it to stop, but I got it to like the normal kind of slow drip. But then that wasn't enough for me. I was like, you know what? I bet you I could, if I just tweak it a little bit more, I can get it to where it'll stop for tonight, right? And so I went in there and I started tweaking it a little bit more, and it just made it totally worse. And then I lost what I had. I couldn't even get it back to that point. It just started to like, it was more than just dripping. It was like starting to run. And I was just like, oh my gosh. And I was like, I can't go to bed and have this steady stream of water. Well, first of all, I think I'm going to hear it. So it's going to sound like unintentional rain in my shower. I was like, I can't do that. So I wound up turning off the water to the house so that it would stop. Side note, in your house, do you have a separate cutoff for your bathrooms? I mean, I thought every house should have that, but mine doesn't. And so I'm going to have to get that installed because, like, if you want to work on the bathroom, well, you shouldn't have to turn off all the water in the house. That's just a side note. So I went back. I messed around. It dripped. Fortunately, I had already gone and done some research on the parts and doing the replacement prior to when I was kind of investigating earlier on a month ago or so. So I knew where the part was. I went over to the store, got the part. I knew there was a possibility of the valve being stuck in the pipe in the wall because I had tried to pull on it before. But in looking at the parts and reading online, I said, oh, well, there's a little adapter that comes with the replacement part that you put on the valve, and you can use a wrench and torque it, and they have like a little, not grooves, but little slants. And it's designed so that if you can twist it, it'll pull itself out a little bit. So that's cool. But that is really only for like brand new installation because this thing, I don't know how old it is, but it may be like the original. I don't know. It was old. It felt old because trying to twist it wasn't going anywhere. Nothing was happening. So, yeah, so I needed a valve puller, and I could have bought a valve puller for like $15, $16, $16.50 with some change or something like with tax, right? I could have done that, but me being the engineer that I am, I said to myself, surely I can figure out a solution so I don't have to spend this extra little $15, $16. And that is the journey that I took on yesterday. I will say, spoiler alert, it worked. The solution worked, but I'm going to save it for the blog. So if you're interested in knowing what happened, the whole story, I'm going to have it in the blog post once I complete that. So yeah, it's pretty interesting. I think I'll be able to make a little bit. I recorded much of it, so hopefully I'll be able to make it into a video that I put on the YouTube channel as well. So yeah, I think you'll find it interesting what I came up with as a solution. I will say it would not be for the average person. There's certain prerequisites that you'd have to have in order to have this solution. So it's not a solution that anybody could do without some other stuff. So you'll see it in the blog post. But I had fun long as it worked. You know, so I was having fun, you know, kind of not fun. I don't know, it was fun. I was encouraged that it was going to work, and thankfully it did. So I'm happy. I'm loving the new the valve is just like night and day. I didn't even realize that the valve that we were using was stiff. You know, you go turn on the water and it's like, I didn't even realize. I was like, oh, well, it's firm. I'm thinking in my mind, oh, it's just snug and firm. Get the new valve, and the new valve is like butter. It's like, you know. So I was like, oh, well, my old valve was really old. It really needed to go. So, and I will say, I had a thought. I was thinking, because I was reading online, I was like, oh, well, you can just buy the O-ring kit or a replacement O-ring kit for this valve and not actually replace the whole valve itself. And I thought about going that route. But then I also saw a large amount of reviews online that said, oh man, don't waste your time getting the kit, the O-ring kit. The O-rings aren't the right size, blah, blah, blah. So I said, you know what? I'm not going to take that chance either. I'm just going to, let me just go ahead and get a new valve stem or cartridge, however you might want to go, valve cartridge. So yeah, but so far I'm very happy, and you can definitely check it out on the blog. I don't have the blog mentioned yet. I have to get it written down on the stream, but the blog is trsrobotics.blogspot.com. Oh, I'll put it in the chat. Oh yeah, we have the technology here. So the blog, blog site, robotics at blogspot.com. But I need to finish the post first, actually. But there's other stuff there as well. All right. Okay, well, we've made it through another episode. We've made some progress. Now it's like that incremental progress. You know, we talked about earlier about that whole 80-20. The 80% part is easy. Those are the big swings, right? That's if this is a wood carving, it's the big chops, right? Chopping it down to workpiece size and then chopping off the major angles. But that last 20%, you start getting into that fine details, like, okay, well, this needs to be tweaked this side, this needs to be tweaked this side, blah, blah, blah. So we're getting there. But I'm still excited. I'm very much excited. And I definitely want to see this finished. So we're getting there. We'll get through this battery box. I'll do some modeling behind the scenes and see what else I can come up with, if there's a better approach. But I'll get this battery box. I'll get the door secured, and then we'll move on. We'll see. We'll revisit that whole LCD thing. This is fine for now. I mean, I'm not going to be in the rain, but the thing is, eventually, I would like it to be covered just for dust and just, you know, you don't want it exposed like that. So yeah. All right. Oh my gosh, I got the hiccups. Goodness, hiccup. All right, thank you again for tuning in, checking out Design and Chill as I design my custom radio controller, radio transmitter. I'm going to keep doing these. Look for me at noon. So far, noon is working, so we'll keep doing it at noon. I should see you guys on next week. And until then, keep modeling. Keep doing what you're doing. All right. Peace.